So my name is Joanna Stama and I'm solution consultant for TIBCO Software, and we are going to see today how you can use data management to actually optimize the value that you get from your data. Since we are doing a demo today, we just have to have the disclaimer on. So actually, how do people feel when they hear the word data, right? We have people that actually don't care about it, because if they are developers, they think the applications that they are working on are not reliant on the data. We have people that worry about it, or people that are excited about the information that they can get out of it. There are three ways that we can look data at. It's the operations way. In an operation context, all the processes that we run in our organizations run on data. For example, you cannot process a customer order if you don't have the data about when was the purchase made, what did he bought, and so on and so forth. In the analytics context, every performance analysis or predictions that we want to make on data, even if it's machine learning or artificial intelligence, it relies on data. It's either data that you already have or data that has been obtained by the operations that we previously run. And then we have the governance context of it, which is we wanting to know who did what on the data and who is responsible for each action in order to make sure that it is compliant to our internal processes as well as external regulations like GDPR and so on. All these three contexts fit into the data management. Data management is basically a business-led practice which is made by people, processes, and systems that interact with our data that ensures that everything that we use inside of our organization is data that's being accurate, consistent, and valid. So life used to be simpler, right? We used to have a data warehouse and a simple reporting tool on top of it. We had designated users for each operation. We had people that were managing the data warehouse, someone that was taking care of the reporting, someone that was analyzing it, and so on and so forth. The reality actually looks like this. In today's ecosystem, we have different data sources that store different type of data, right? With different structures. We have structured and unstructured data. We have data stored into cloud, in big data, files, and so on and so forth. And we don't longer have just the basics and standard reporting tool. We now have self-service application. We have users that want to connect and try to build their own reports, do their own analysis, and then they want to feed that information into machine learning and artificial intelligence. The first problem that we have with that is data quality. Having different sources and different data coming in, we might encounter quality issues. Why is that important? If you look at this, 20 years ago, NASA lost a $125 million orbiter just because they had two teams working with the data. They assumed, not having a process in place, that they are using the same measurement units. A team used English units like miles and feet and so on, and the other used the conventional metric systems, meters and kilometers. Once they calculated the trajectory of the orbiter, they launched it and they realized that it was all the wrong math. In a business context, because it happens in today's world as well, there are two costs of data operation, right? So you have the human factor that's involved. If you have poor data, you will create a lack of trust within your organization, and you'll need people that will actually have to fix and rework everything. That will get them frustrated, it will get you lose a lot of money. There's a cost involved as well. You have to pay those people, and you have to make sure that your brand or your business doesn't suffer from the decision made by poor data quality. There are actually studies that show that by not having processes in place, businesses lost in total, just in the United States, $3 trillion per year. So what's the technical solution for that? Is to have a 360 architecture for anything. What we are looking here, and we are going to see in a demo shortly, is how you can use technology in order to create a 360 view for anything, and making sure that all the information that is running through your organization is being governed by the same processes. It has people responsible for each step of the process. You can audit and monitor that in order to see what happened and when. And you can feed specific data to specific applications and users in the way that they want to actually see it. So we are going to start with analyzing the data, because basically that's the visual of what we are seeing. If we don't have consistent data, the visualization is not going to be the thing that we actually want to see. So what we'll see today is how the data looks for the end users and how actually it got there. Okay, so we are seeing here, using the TIBCOS platform, how our sales evolved per region. So we have different regions and different number of customers. Then we have for each region each year a different chart where we can see the evolution of the number of customers and sales each year, right? We can select all the years and then drill down. If I click on any of the squares in the bar chart over there, I can drill out to exact information about that customer, right? So me as an end user, I only have specific columns that I have access to and specific things that I can actually see. But how all of this got there, right? So we have two components. We have the shared data assets that are the DNA of our business. By shared data assets, we mean master data, reference data, and metadata, right? So master data is the entities that we use within all the units of our organization, and we want to refer at the information we have about them the same way regardless of the unit that is handling them. So for example, you have employee information. The management team, the HR, the payroll, they will all need the same information about the employee, right? They all need their name. The name has to be the same for everyone. The email address has to be the same, and so on and so forward. Then we have the reference data, and that's the way how we classify things, right? So those are values that are previsible in all the units and operations that we are performing. For example, geographic data like cities, capitals, countries. Those are informations that we can use regardless of the type of operation that we're doing. And we know those are not going to change over time. The same goes for industry codes or maybe currencies and so on and so forward. And then the next aspect is the metadata. So basically the data about our data. We have business terms, we have policies around that. We have to make sure that the moment a business user sees it, it's able to understand what's in that specific table and which columns he needs to go to for information. And that's important because any type of change will gather big consequences. If it's I don't know, maybe a wrong column name or a wrong data type, a quality issue will generate something wrong in the analytics or maybe the operations. If you are not aware on what's in each table, you can have compliance issues. For example, in GDPR, you need to prove someone that you have deleted all the information that you own about them, and you have to make sure that you are able to prove that. Oops. Okay. So the first step is to master those data assets. We have different sources. For example, you have information about the customers that you see previously in different systems, right? It's either a CRM or files or other external applications. You can see now on the screen how we're going to actually master that. So this is a part of TIBCOS platform. We have different domains that you master in the left-hand side there. And we have a golden entry for each of our companies. We can from here manage them further on, compare them, delete or validate it. When you create the model, you make sure that you have the right validation. Based on that model, you have different hierarchies inside your data, right? So you can display it and visualize it based on different approaches. And I mentioned the data model that is popping up now on the screen. So this is the table structure that we actually have behind, right? So we have the customer information, the companies, in this case, the roles that the company has for us. It's either a supplier or someone that we sell to. We have the reference data associated to this, which is the activity sector in which the company works in, the applications where the information is coming from, the sites or the place where the company has headquarters, and the countries. These countries are reference data that are used for all domains within our organization. To make sure that the data in here is accurate, we have in place a workflow. So a series of steps that allows us to understand who does what in the process of adding a new company. So we have automated scripts or user tests in there. Someone has to trigger the process right? We have to monitor and see who did it after they fill in the form, and we're going to see how there's someone that has to approve and verify the data. So we not only have validation in terms of technical validation, right, at data model level and so on, but we also have validation toward the process of inserting data in. So we have someone that's looking at the data. We might have automated scripts and tasks in there as well. I'm realizing I'm talking very fast, and I'm sorry about that. So let's see how a business user sees it, right? So here they have some metrics about the quality of the information they are looking at. We see they have completeness rate and so on and so forward. The moment they try and go and create a new record, right? So they go there, they see all the attributes that they have to fill in, they press the create button, and then a form will open. In order to make sure that we have the right data in, you can set validation to each and every single input, right? And any type of developer will develop controls on each step, right? So we fill the data in, we have reference data to pick from. In here we have, you saw the table has a foreign key relationship to itself. And actually want to improve that data with external information. In today's ecosystem, people use open source technology and open source information in order to enhance the quality of their data. In this example, we are actually using Google Maps in order to make sure that we have a standardized address that we can further use on, right? So this is an API call that's making sure everything it's in order, and it's pinpoint me on the map where the address of the company is. Once I save it, I have to send it to validation. Someone has to make sure that the process we saw previously that something happened. I don't know what. Okay, sorry about that. So this is how the steward is going to approve my information in there, right? So he goes in, he sees there's someone has created a new row, and you can see in the bottom side that actually he has access to other type of information as well. So you can restrict the things that the users see based on the permissions that they have. That's a way to ensure that you give access to the right people. Once he approves that, he has to comment on it to make sure that we know who did what and actually what's the incentive behind it. If we go back to the business user platform, and take a look at the steps, we are going to see that they created it, and there's a specific someone that has validated their entry. If you go and check for it, you can see the data has appeared. Even if the steward has improved the data quality in there, if he did any alterations, or he added the billing information, if he added information that the business user is not able to see, they're not going to see that in here, right? The next step is actually link it to transactions. If only we have master data, that's not enough for us to drive business decision fast. And the concept that we're going to use today is data virtualization. That means that we don't have to move data anywhere. We don't have to create an additional data warehouse in order to add additional costs in terms of licenses and people that are managing it, but we are actually creating a virtual environment for it. What does it mean? It's actually creating data as a service or a data fabric, right? So we have different type of data sources that we are connecting to that are feeding into different type of applications. The point is that each application will need data from different systems, specific data, specific columns, but we don't want to create a table for each application, for example, a physical table, and we don't want to give the user the burden to actually go and select the columns and waste time into doing that. So that's how we actually create a virtual environment. Our approach will be to connect to all the sources, right? Create a one-to-one virtual replication. Every time I'm querying that virtual layer, it will go back to the sources using an optimizer, and it will bring back the data that I need to, right? So it's not going to move it anywhere. Once we have a one-to-one replication, it's easier for us to create a business layer, right? So different units of our business treat the objects in a different way. We have business objects such as customers that is actually different depending on the organization and maybe the unit that is using it, right? So we create our business objects, and then we make sure that we feed them into an application layer. What that means? It means that we create a specific data set for the applications that we're using. Every time the application is connecting to that application layer, we are going back to the sources and bring the data up using an optimizer. So we make sure that they have the most up-to-date data if something happened in the source systems, right? And we also make sure that if something changes, if we drop a table or a column, or we need additional information, additional columns to that, it's just very easy to bring them back in. It's not necessarily a matter of adding more tables and loading the data and doing bad jobs to bring everything overnight that changes. So after we create a virtual layer, we ingest in it the master data as well, because we have to link that to transactions. There's no need for us to copy them from any type of repository. We create the same virtual link to them as well. And if we will see here, we have created a connection to different systems. One was a SQL server. We are also using web services to connect to data, as well as CSV files stored in the file system. So we have drag and drop everything in a single place. We have the customer, that is a web service. We have the transactions that are coming from a CSV file in this example. We have the reference data that is coming from either a web service as well as a relational database table, right? Once I run this, I can see all the information that was available in the initial report that we saw, right? I just have to drag and drop them here. Every time I need to add something else, I just drag and drop a new table. And the moment I pick the columns that I need for the application or the user, there's a drop-down list here that allows me to pick which columns I need. So if something changes, the need for the end user changes, I can just go and add a column. You can either write a SQL script. This is automatically generated, and it's an ANSYS SQL to make sure that regardless of the underlying source, it can be executed. You can take a look at the execution plan as well and see what's the best and performant and faster way to access your data, right? You can influence this as well if you want to, and maybe this optimizer is going to take into account what happens with the transactions in your systems as well, right? Because if you have a transactional system, you don't want to overload it with the burden of querying it even more. But once we decide to do that, we are going to look at the lineage, so where the data is coming from, right? That's really important in the governance process and to make sure that we are compliant. So we can see which are the sources, where the information is coming from, how we can bring it together, if there are any transformation that happen in the way. So let's say I want to delete a customer record, I can see from where all my customers' sources come from, any type of transformations, and then I can prove that I've deleted them from there. Right? But we create this virtual environment and then we give access to end users to it, right? But what happens if we actually want to restrict the access of those users? We are creating something that's called row-based or column-based security. So basically we are limiting the number of rows returned on the number of columns. Here we have created a limit for the number of rows that are being returned in order to make sure that the users won't see all the information. So what the policy is doing here is, if I log in with a different user that's not the administrator, I'm going to see no rows in the table. I'm able to see the table and the metadata structures, but I'm not able to see the contents. If I'm the admin user, I'm seeing the contents that have a specific value in a specific column. If I go back and test that, so this is how the policy will look like. We just click it and the tool generates the SQL for it, right? Once I run it, if it moves faster, we are going to see the results of the querying, right? So we are expecting to see, since we are logged in the administrator, a bunch of rows, but have only connector and other in the column in the right? If I test my identity and I try to run that with a different user, for example, I'm going to see there are literally no rows returned for that user. He can see the structure, he can see the table exists if I want to, but he cannot see the information inside, right? So the step-by-step flow for it will be, you have your sources that you want to manage your data from. You want to have access to that very fast, right? So you create a virtual environment, you take advantage of your shared assets, and then you feed that into the analytic tools. So unified data and governed processes will enable you to have faster analytics and ingest any type of additional open source technology in order to enhance your data or take advantage of that. That was the Unify part of our story. So we can also help you augmenting and connecting your data. And if you want to see an end-to-end flow live, we invite you to our F1 simulator to see how we can get the data from the car that you guys are driving, analyze it and display it on the screen, and actually measure the performance of your driving skills. And that would be all for me. If you have any questions. Oh, thank you.